can share the code line. Yeah. Now is it visible? Everything is good? Shall we good to
Ashwin.
start? Yeah, good.
Yeah.
Okay, so today the concept is what we are going to learn is support vector machine. Okay, support vector machines, SVM. Okay, in short, we can call it as SVM. This is another machine learning algorithm. So far, we learned linear regression, logistic regression. We learned. So today we are going to learn about. Okay, let me add one more person. Let's just started. Okay. Hi Prajwal. Just now we started. Okay, support vector machine. This is what the algorithm that we are going to learn today. This is one of the most commonly and widely used in most of the use cases. Okay, if you see in the Kaggle, okay, most of the use cases you will find this algorithm being people are being using because maybe I mean, it is not that this is the finest algorithm that I can say, but mostly they prefer to use a support vector machine. We actually in the right scenario, according to the rule of thumb, we have to try all the different algorithms and whichever will be the right one, we have to choose that one. How we'll get to know that? Because of the accuracies of how what we are gaining out of all the different algorithms. Okay, here, if we talk about support vector machine especially, this is one of the powerful supervised learning algorithms. Again, let me revise you. Supervised means there should be a labeled data, obviously. If we have a labeled data, again, we have to have two questions in us, whether it belongs to regression or classification. How to define whether it is belongs to regression or classification means mainly depending upon the output column what we are dealing with, output factor. If the output column or output feature is continuously arranged, then we have to go for regression. If not, means classification. And in again classification, again we do have many algorithms are there. So first we tried it with logistic regression that was already completed. So now it is time to learn support vector machine. It is another algorithm which we are now using it for classification. But support vector machine is also applicable in regression as well. If we use it for regression, then it will solve to find the best fit line. But if we are using it as a classification means, it will help us to define the classes correctly, or it will help us to define the classes and it will help us to make a decision according to the input data which class it belongs to. Okay, here I mentioned that one also. Supervised learning algorithms it is used for both classification and regression, but the actually aim is to find the optimal hyperplane that separates data points of different classes. I will soon explain you what is this hyperplane, what does this separation means. It is really interesting and very helpful to you. First of all, um, we have to explore. Let us explore the key concepts of SVM. Key concepts are includes marginal maximum marginal classifier. What exactly that is? Then soft margin classifier. Then kernels. Then model building and evaluation. How exactly we can make use of this SVM algorithm, and also with some explanations. First, maximal margin classifier. When we talk about this one, this is simply like we are going to classify the data points with the help of hyperplane. Okay, that hyperplane should have again two lines, so that lines the distance between them should be maximum. That I will show you with the help of explanation. Afterward, okay, let me show that, and then we'll have a discussion of this. Let me open a PPT. Blank presentation is enough. Okay, here I'm going to show you one thing. So the goal is, so far we learned, okay, if this is our plane, I mean, if this is our things, let me take some data points. Let us say this is one point, this is another 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 point. Okay, and let me take some other color. Maybe I can take this, 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 and this. Okay, so there are two classes. Let us consider there are two classes. One class is this one, or what is that, red color, and another class is yellow color. So I have to take a decision. I have to take a decision. The new point. So this is new point. Let us consider x1, y1. That new point can be here, black colored. Okay, can be here, can be anywhere. I will center it. Okay, this center represents the new points. So we have to find out these new points belongs to which class. This is class A, class A. Let us consider these are class B. Okay. So I want to find out these new points belongs to whether class A or class B. So classification is simply like we have to define a class, right? So whether it belongs to class A or class B, isn't it? This is what my end goal. Got it? This is something like x1 and this is y1. Let us consider. So if we plot all our features here, so we have a situation like we to define the new points to the new correct class. This is what I wanted to find out. So when there is a task like this, okay, how to solve this? So we know we know linear regression. Linear regression, if I have points like this, okay, it is a regression means the end thing is I have to come up with a perfect fit line, best fit line. It is also called as best fit line, which is y is equal to mx plus c. Okay. So if I find this y is equal to mx plus c best fit line, which is nothing but I already told that the difference between the actual values and the predicted values, the difference, this is what the cost function, the difference should be minimum. So whichever the line gives you the minimum square of errors, okay, that is what the best fit line. So for that, it is not coming directly. I already told that this can be the fit line, this can be the fit line, this can be the fit line. There are multiple combinations are there, iterations are there. Whichever, but the criteria is whichever gives you the less error. Okay, and that is what the best fit line we will consider, and we will use those values of m and those values of c. Correct. If you don't want your y-intercept, I already told that in linear regression, we can even skip that y-intercept. We can always focus on the centered fit. That is also there, but in general, y-intercept also there by default. If I find that best fit line m is equal to 2 and c is equal to 10, let me say that, and whatever the new point x1 is equal to, let us say 30, I wanted to find out y, means simply I will replace the values. Mx plus c means 2 into 30 plus 10, then I will get 60 plus 10, 70. 70 will be my y value. This is how I can predict using regression. And again, in classification, I told there will be two classes. Okay. So we can use logistic regression, a sigmoid function with a threshold of 0.5, and we will find out the 1 by 1 plus e power minus y sigmoid function. This y is nothing but same again the straight line equation. Then I will get the values in between 0 and 1. Whichever values above 0.5, that class belongs to 1, and less than belongs to class 0. In that way, that is a strategy or that is the mathematical intuition to calculate or to find out the the classes in classification, and that too logistic regression. But when it comes to SVM, what is the scenario or what is the mathematical intuition or how exactly it works means, let me take a new one. Hmm, okay. Okay, here this again I'm considering the x-axis and y-axis. These are features. This is output column. Okay. So I let us consider again two classes are there. This is class one. This is class one. Okay, and this is class two. This is class two. In support vector mission, what is the strategy or what is the mathematics or what exactly the algorithm we are going to do is we have to find out the hyperplane, the best hyperplane. So that this hyperplane actually we have to design in such a way it has to divide the two classes correctly. So I mean correctly means as much as it can. So if we can find out the hyperplane formula is always be W transpose X plus B equal to 0. Okay. So if I can find out a line equation like this, okay. So then what can I achieve is future point. If there is any future point, let me say this is a future point. If it comes here, this future point is under this line, then this will belongs to class yellow. Class yellow. If my future point is above this line, then this point belongs to class red. Is this clear? If I can form a hyperplane in such a way to separate the two different classes correctly, so that it will help me in future if there is any point I wanted to predict, I can easily find out which class it belongs to. Is this point clear? Is this point clear till now? What is
Yes,
support vector
Yashwant.
machine has to be done? Okay, very good. Thank you. Now, there might be a question. There might be again a question. There might be a question. Okay, then what happened? You know, is this the only line that I can draw? No, I can even draw a line like this. Right? This is, let us consider this is also a straight line. I can also draw a line like this, a line like this, or line like this, or line like this. Then which line is actually best suited line? Okay, which line is actually the best suited? So, when this situation arises, then we will consider the concept of hard margin. So, what is this means? So, again, what we will do in hard margin is, so instead of one line, we will draw a line here, another line here, in between hyperplane we will draw. So, same way, whenever you wanted to separate, so you can come up with three instead of one. We will call it as these two are like planes again, one for positive, one for negative. So the between the one which divides is actually will help us to define or to decide the factor. For example, so if there is any point here, it go and classify this is one, or below this is the one. But this line will actually define us the decision boundary. Okay, separating the two different classes correctly. So then the question is, I can also draw three lines like this or three lines like this, but which actual three lines are you know very important means when, so let us consider the distance between these two is d1 and this is to d2. Total distance is d1. D is equal to d1 plus d2. The distance should be maximum. The distance should be maximum. So wherever you find this distance, these three lines distance, okay, maximum, that three lines will be considered, not the other ones. Got it? So let me show you here. Now let us see this picture. Here you can see the blue points and the yellow, the green points. So you can draw any type of decision boundaries, right? Red line, purple line, or yellow line. But what will be the best one? So the primary goal is to find out the best hyperplane, which is a plane again that is further away. It actually furthest away. Furthest means the distance between the thing is will be more. That is what maximize the margin. This is accomplished by identifying the various hyperplanes that is best to classify the labels, after which actually it select one which has the largest margin. That is what I mentioned. Okay, here you can see. And what is actually meant by support vectors means, here you can see support vectors being identified here with red color. You can see support vectors are the vectors which are actually the outer line, okay, touching points. Here you can see this point, this point, this point. These points are called support vectors. In support vector machines build with the help of support vectors. The support vectors are actually these points. This is called the in between line is called the optimal plane, optimal hyperplane. Okay, how actually it works? It works basically with the help of dot product. Let me show you how actually it is going to work. Okay, let us consider here the data points again. Here I will not use again colors. This is the separator line. Okay, or let me take in this way maybe. Array, sorry. Yeah. So here consider this line. Okay, not centrally arranged, so it has to be again like this. Okay, so let me take 2 points. One point. Let me consider this is minus 4 comma 0. This is x values and this is y. And some other point. Okay, here maybe this is plus 4. Okay, and some y value. Okay, 4 comma 2 or 4 comma 3, any point. Okay, so here, if you calculate this one, W1 transpose X plus B. Okay, so if you calculate this one, what is this W1? It is a kind of a slope of this line. So let us consider the slope is minus 1. Slope equal to minus 1. Okay. So transpose, why we have to consider transpose means I have to do the matrix multiplication. You know that, right? Matrix multiplication, for example, it is 2 into 1, 2 rows and 1 column multiplied with anything which is having 2, 1 row. Okay. 4 comma minus 4 comma 0, right? First values. This is 1 row and 2 columns. So these should be same, right? Then we will get 2 into 2 matrix, correct? So we will get 2 into 2 matrix, same. Here, that is the reason why I should consider transpose here in order to perform matrix multiplication clearly. Here the points are minus 4 comma 0 x and slope is minus 1. Let me consider my bias is 0. Okay. Then minus 1 times of 4 minus 4 is 4. Okay, minus 1 into minus 4 is 4 and plus 0 into anything 0, right? Plus 0, then this value is 4. 4 means positive. 4 means positive. If you consider and same calculate about this point, minus 1 0 again W3 transpose, but x value now onwards is 4 and 3. Minus 1 into 4 minus 4 plus 0 will be minus 4. Okay, so this point I got minus 4. If you consider any data above this thing, any points, this point, this point, this point, you will always get negative. Okay, you will always get negative. Similarly, if you consider any data points here, 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 you will always get positive. Got it? You will always get here negative, you will always get positive. Then, uh, then here the question is the hyperplane, how it will become. And first of all, the plane, we already know that how to separate the points because we have seen it in linear regression also y is equal to mx plus c. that will help us to draw a perfect fit line. Okay. So the perfect fit line, you know that that is what the slope, that slope only we will take. Okay. So to separate the points correctly. And then what is the main challenge here is the distance between these two, the distance between these two should be max, right? Maximum. That is what we want. Okay. So how we will get means this is x1, this is y1, let us say. The distance means x2 minus x1. So should be the we have to maximize this. I will tell you how it comes. So let us consider this equation is wt transpose x, okay, plus b minus 1, because you know that above these points are all minus, right? That is why this is equation number 1, and this is all plus ones we are getting. Wt transpose plus b is equal to plus 1. Okay, this is equal to minus 1, this is equal to plus 1. And if you solve these two solutions, okay, this minus we will get, minus we will get, these two being calculated to 0. So x1, this is x1 points, this is x2. X1 minus x2, okay, wt transpose is equal to minus 2, isn't it? If we minus the things, I mean, if I take the minus common, then x2 minus x1 w transpose equal to plus 2, isn't it? Then so I need to remove this w3 transpose, then I have to divide with this, right? We know that I can pass. Then this is not the way. Here directions and magnitudes are involved. So that is why both the equations I should divide with normalization with W, double norm. Then this will get removed. Then this is what the formula. And we have to do wherever we get, the two different lines. The two different lines, if we can get this particular value as maximum, then that is what the one we have to refer. Is it clear? Is it clear? The center one will be then W transpose X plus B is equal to 0 then. Because this side minus 1, this side plus 1, the center one having this parameter Wx plus B is equal to 0. Now is this clear? So mathematically how it will be defined is this particular parameter, wherever the planes, two planes having the maximum value, that lines will be considered, remaining will be eliminated. Is it clear? Can I get a quick confirmation? I have found, is it clear by the way? Let me know.
Yes, Ishwan.
Okay, clear. So that is the way how it
Yes,
actually
Ashwin.
works. Yeah, yeah. So there is one good reference material that I found to explain this concept clearly, because all mathematically it is derived. So here let us go through this reference material so that this concept will very well delivered to you mathematically. Here let me go from the beginning. Okay, because I took this content, some of this content as reference. So this is really nicely elaborated, mathematically elaborated. See, first of all, support vector machine we already covered. You can go through this material also. This is analytical vidya slash support vector machine. If you type, then you will get this material. The same images I took it to explain because it is very well explained. Here advantages also given. Please refer these exam advantages so that you will get to know what are the main advantages of being using support vector machine and what are the disadvantages, also very important, so that you can easily in future, so that you can easily evaluate which is the one we have to use it furthermore. Okay. And when it comes to the mathematical intuition, I just now I told you the dot product is the one. W transpose X we just defined, right? The dot product is what very important. The dot product means, A dot B is equal to mod A cos theta into mod B. Mod means magnitude of the vector. So here you can see and you can easily go through, this is what it is defined as C. So X transpose X bar means direction in the same direction of W bar is equal to C. This is what the point lies on the decision boundary. Okay. If any point lies on the decision boundary, this is what the one. equation. And if it is greater than, then it is called positive samples. Less than means negative samples. The same one I took it in a different way. Okay, I took it in -1, +1. Where here the um, what do we call, variables may be different, but actual concept is same. Okay, so see, w dot x plus b here is equal to 0. This is what the plane, and this is what negative plane. This is what the positive plane. Okay, so the points which touch these points, those points are called support vectors. Okay, here it is very clearly explained. +1, if we take this one, just now I delivered the same way. So y is going to classified. Why is he going to ultimately we need a classification algorithm, right? Which has to tell me which class it belongs to. Logistic regression, we understood it is a sigmoid. If we pass those regression equation into the sigmoid, we will get the values, and 0.5 and above, that is what the class been defined. But here, this is the one. +1 means one class, positive class. It is going to define if these values been greater than or 0 or equal to 0. You can see, or equal to 0, or less than means if it is going to -1. Clear? This is the way how to define any point, whether it belongs to this point, this side, or this side. And anyway, we need to know this maximum, right? Here it is very clearly mentioned how to know this maximum by considering these small equations. 2x plus y minus 2 is equal to -1. This is one thing. 2x plus y minus 2 is equal to 1. And there is equal to 0 is the one which defines the hyperplane. With the help of that, if you go slowly down, then you will get the ultimately 2 by mod double mod w. That is what the distance formula. Okay. So this this maximum only you need. Okay. You need the maximum. That is what the ultimate goal of hard margin SVM. Okay. And you can also refer to the soft margin. Soft margin means real world data sets are rarely perfectly linearly separable, right? Then we often go for non-linear separable. So non-linear separable and methods which are there for linearly separable data don't work for this case, because in reality, if we have such things very clearly defined which class it belongs to, then we can consider those are hard margin, and then we can simply use that. With pen and paper also you can easily solve, isn't it? If you find line equations and all. But in reality, here it is very clearly mentioned real world data sets are very rarely perfectly linearly separable. Then what is the plan B? Then plan B is we can go for soft margin. So here the soft margin in such a way, it is very clearly mentioned. This parameter, hyperparameter is going to add it. See, this hyperparameter is going to add it. Okay. So this hyperparameter value will actually defines that, see here you can see if it is any misclassified, this plus buttons, okay, minus button. So it belongs to, actually it lies in between this hyperplane and this separable line, right? So then it is, if you read this one, then you will get understood. For all correctly classified points, our zeta will be equal to 0. For all incorrectly classified for the zeta, it simply the distance of that particular point is what correct hyperplane. That means if we see the wrong classified points, the value of zeta will be distance between L1, L1 hyperplane. These are L1, this is L2. Please go through this. You will easily understand. So basically, we are going to we add two terms. One is zeta and one is hyperparameter C. Hyperparameter C is C. This one, then this is zeta. This zeta, what exactly it do, and hyperparameter what C, what exactly it do. It is very clearly mentioned here. The error is always margin error plus classification error. Okay, and these C values actually, if we iterate with different values. Okay, if we iterate with different C values, we will get you can see, observe the two different figures. Okay, so it is actually hyperparameter. The values will get changed if we keep on changes with C values. Then how will we get to know the best C value? It is just a trial and error. We can try with one C value. We'll see the classes classification, how it is being done. If it is not very perfectly matched, then again iterate with the next value and all. Okay, is that clear? Is that clear till now? Till now? Till now, is that clear?
Yes, sir.
Yeah, very good, very good. So now the real challenge is there. One more challenge is there. Arey, where is my cursor? Yeah, now the real challenge is there. Observe this figure. Observe this particular figure. If you see, this is not, points all at one side, another points all at one side. This is a club, right? Centered, isn't it? So then, how will we going to solve this type of problem statements? I- If we have any data points like this, which is clearly defined, we can use either hard margin or soft margin. Soft margin means where we will be having, the hyperparameter C and zeta. But in a hard margin, no need, directly hyperplane we are going to define, and we have our end goal is maximize the 2 by norm of W. Okay. But here the situation is different. These are not kind of separating the points. This is a kind of a club of points. Then how will we solve this? Then we have to use kernel concept. This is what I mentioned here. Then we have to use a kernel concept. Using this kernel is simply like we are going to change the dimension from lower to higher. If we change the dimension from two-dimensional to three-dimensional, just observe this figure. The same points only will be plotted like this. Then instead of line, we will take a plane. This is what decision surface. We will take a decision surface that will actually divide these two classes effectively. Is that clear? Why do we require kernels? When do we require kernels? Is that clear? Is that clear? Can I get a quick confirmation? When do we require kernels? It is very important thing. Do we require kernels in all situations? No. Whenever you see this type of things, where the actually values are being clubbed, okay, where there are cannot separatable by linearly. Okay, if you can see there are we cannot perfectly draw that hyperplane, right? We cannot draw hyperplane in this situation. We need, but still we need to classify them into two different classes. Then what is a way to do this? Then we can go for kernels concept. Is that clear? Kernel? Why do we need kernels in SVM? One good question actually in interviews. Is that clear? I can take it as yes, silence. Okay. So if we do this, then it is ultimately what it is going to do is it is going to convert the lower dimension to the higher dimension. Got it? Lower dimension to the higher dimension. That is what kernels do. What are the different types of kernels again? First one is polynomial kernel. The simple mathematical formulation is this. The D is a degree. Okay, here you can see D. D stands for the degree. And then, you know, picture, you can see this is the way we are going to separate instead of a line with this kernel. Okay. And then sigmoid kernel will be like this. Okay. And then RBF. This is very important one. I also provided a short notes here, kernels. So here you can see linear kernel, polynomial kernel, RBF kernel. These three are very important. What is linear kernel? It is very suitable for linearly separable data. We can go for linear kernel. By default, SVM algorithm is built by linear kernel. Polynomial kernel means handle complex relations, considering the polynomial combination of features. Polynomial combination of features are already told in linear regression, right? So if you find that degree is involved, that points are being polynomially arranged, then polynomial kernel we can use to separate them. Then radial basis function. This is what RBF. This is actually captures the local relationships by considering the distance between the data points. How exactly it works means, see, here you can see. Okay, so this is the picture of the radial basis function kernel. Okay, so that we can capture the most of the points, though it is not linearly arranged. Uh, okay, and also some more also there, Bessel function kernel, ANOVA kernel. But these three are very important. Okay, polynomial, linear, and RBF. In general, linear and RBF is what we actually use in general. In general, I'm not saying it is common in everywhere. Okay. So also there is one case study is given here. Please go through how do we actually define with different things. Okay. So that is all about support vector machines actually. Support vector machine basically. Here one more thing. Hyperparameters in support vector machine are, if you change these values, then the results, the outcomes will get changed. What are these hyperparameters? Mainly four hyperparameters are important. First one is regularization parameter, that is defined by C. C, we just saw a soft margin, we have seen C. It is kind of a trade-off between achieving a low training error and maintaining a smooth decision boundary. If you take a small value of C, okay, that allows large margin is required, potentially leading to more misclassification. Obviously, right? If your margin you are increasing a lot, then it may goes to the mislead or misclassify on the training data. Okay, but large C value aims to classify all training examples correctly. It actually, but we have to be very specific when to cut down or what value we have to consider and all. It is a kind of, I mentioned, trial and error. Kernel type, which kernel? Linear kernel, polynomial kernel, or RBF kernel, we have to choose and identify according to the problem statement. Then degree of the kernel, degree of the polynomial, what exact degree we have to take. If it is polynomial, again, if it is polynomial, then only degree. Then gamma is important. Gamma actually what will happen is, let me show you here. If the data points are like this, I will take new slide. Yeah. So gamma value is nothing but, if your points are like this, if your points are like this, another points are like this, another points are like this is 1 point, and this is 1 point, this is 1 point, this is 1 point. Okay, then you have to define the kernel. Based on that, it will actually do like this. Okay, so it actually do either like this. Okay, so it actually in kernel, if we go for higher dimensions, we can divide like this. If your gamma is been increasing, then the depth, the intensity of this curve will get increase. That means it may go, if you get keep on increasing, it may leads to misclassification. And again, if you lessing it, it may leads to underfitting. Anyway, I will explain that underfitting, overfitting, and regularization, all such hyperparameters in one class. Okay, so that you will get to know what all these terms. Okay, here I mentioned here, you can see, if you take a low C value, what will be the effect is, it will allow for large margin with the potential misclassifications will be there, so that it will promote a simpler model that may generalize it better. But a high value, if you take, it seeks classify all training examples but correctly, can but it will also can lead to a more complex model that will ultimately overfit. Okay, so low gamma, if you take low gamma, then creates a smoother, like I just mentioned, smoother, less complex decision boundary suitable for data which we have less noise. If you take a high gamma, then it produces more complex decision boundary that fits the training data correctly but may capture noise. leading to overfitting. So you have to make sure which gamma value I have to go for, which C value I have to go for. And kernel anyway I mentioned, degree is only for polynomial kernel, we have to add. Remaining kernels, it is not required. Is that clear? These are the values we have to make sure while passing to the data, sorry, to the SVM algorithm. Now let us see one case study. This is case study. This is a case study. Study, because this case study I really liked because everything it got covered. Okay, it covered the EDA part and explanation. So why this step is required, why that step is required. This is a one-stop thing, end-to-end machine learning process. Okay, because it covers all. Business understanding is very clear, and the data set is a very good data set because different type of values are there, different type of columns are there, independent, dependent columns are there. How exactly to solve it in reality? Okay, yeah. So let us try to understand this data set. This is housing data set. This is the column that we wanted to ultimately predict. So it is kind of income which is less than equal to 50K or other one greater than 50K. Okay. So we do have good points like age, work class, government, central government, state government, self-employed, private employee. FNLWGT, what is this? So there is one value I will tell you. Anyway, we are dropping it because it is not a very important factor. So in the data set, actually, it is given. Uh, Let me show you that. In Kaggle, it is available. Uh, where I took this is income evaluation. Yeah, this is the data set. Okay, income evaluation is the one. So this is the data set. So where you can see different values, but here they did not provide very good points. We'll go and check the other thing. Yeah. So these are called final weight. Okay, final weight. This is one value called final weight. FNL. WGT means final weight. Education, higher graduation of some college or others. Okay. So this data set is actually predictive feature like education. With the help of that, employment status, marital status. So ultimately, we wanted to predict the salary is going to be 50K greater or less than 50K. Okay, that is what the ultimate goal. Got it? This is final weight. This education numbers, and marital status, occupation of the person, and the relationship, race, and gender, capital gain, capital loss, how hours per work, how many hours the person is going to work, and native country, what is the native country, and income finally. So the aim is, I already mentioned, we are going to predict whether the person is going to fall under less than 50K salary or greater than that. That is what the aim. Now we will slowly see how actually this author is solving it out. So out of case study, what is the things that we can gain is we will get to know the approach for sure. Along with the approach, we will also get to know that in what way this type of problem statements we have to solve, and we can also add our own way or our own approach of solving it. Okay, first, obviously exploring shape info. In info, it is very clear that there are three to 3 to 5 6 1 columns, sorry, rows. Here also all are 32561 rows, all are non-null values. Means this data set is having null value or not? No, absolutely no, because all are non-null values only. Many times, you remember this point, many times you will receive a data set which is having no null values. That means it doesn't mean that there are no null value at all, or it is not required to do some data imputation. It is required, because I already mentioned you yesterday. I mean, yesterday means last class also. Sometimes instead of null values, people may use symbols to represent it as a null value, sometimes question mark. Okay, we have to identify, is there any such values which been disturbing this? How do we do know that? For example, age is integer. Here if you observe integer, but instead if you observe any object, here object means string, we know that age is integer, but it is showing as object. That means either this age is being given as uh, given as string, or else any question mark is there. If there is any question mark, we know the array concept. Arrays allows only one data type, right? So that means this data set might have one string in the form of either question mark any or any other symbol. In that way, we can easily identify with the help of info function. That is why I told many times, info is very important. Then object, yes, it is also in general object. This is also object. Then it is integer. Yes, it is integer. Education object, and again study and all. Only numerical columns education we have to check. That is integer. Fine. Capital gain and all three next to capital gain are all integers. Yes, it is. So these columns, integer columns, are not having any question mark, something like that. That is very sure. But we have to cross check whether is there any particularly is there any question marks or some type of irrelevant data when it comes to the non-numerical values, also called as categorical values. See, let us see df dot columns. These are the columns. First income column, if I observe, these are the two unique values. That means I am going to have two classes. One is less than equal to 50k and greater than 50k. I have to label it. I have to encode it with a 0 and 1. Then only I will convert the numeric to the numericals, right? And if I know the marital status here, marital status also not having any question mark, because it is very well defined. Divorced, married AF spouse. Okay, and married CIV spouse. I don't know the difference between CIV and AF. If you know, you can add it here. Married spouse absent, never married, separated, okay, widowed. These are all making sense to me, but I had to explore all these things, these three things. If you know, please add. Okay. Anyway, we are not going to consider this column because it is not making any big value or a big impact. Final weight, what is that weight? We don't know the clarity. So that is why we are going to drop that. And remaining columns are these after dropping that. Then we have to rename some columns in a better way: age, workforce, education, education number, marital status, occupation. If you want to alter the column names, I already shown you this step. So we can just specify all the columns and then replace it like this. And then no null values, obviously, because we never seen any null value so far. But there might be null values. How we will get to know that, I will show you. Here just we are going to add one more column called age types and income number. So just to specify, if any label is young, adult, old, we just wanted to add these values as young, adult, old, based on ages, see, young, adult, okay, old, got it? So we just consider bins, labels, and we just need to cut off the data according to the age. Okay, according to the age type. Okay, we are going to add one more column here. You can see age type. And income number is where if any income is greater than or equal to 50, that is what 1, otherwise 0. So this is one more way of doing the target encoding. Okay, doing target encoding, I already explained you target encoding. This is another way of doing target encoding. This is just target encoding. Then remaining things just needed to check if there is any education, how many unique values are there in education: 10th, 11th, 12th, first to fourth, fifth to sixth. Some different educations also may be there, right? Along with the normal one, ninth. association ACDM, association VOC. There are some other PG diplomas and all. Columns, strip columns. Just to strip, it is not very good. I mean, there is not very necessary one. You can directly come to this one. See, in work class, actually, we are having a column and we are having a value as question mark. You can see remaining columns so far we did not identify. The first column we identify the question mark is work class. This is the way unique is the function. I already explained you. Unique, n unique, also value underscore counts. These functions will actually help you to know how many categorical values are there and each categorical value how many times it been repeated. So here question mark is there. I wanted to know how many times it repeated. So here is the code. So where you can run a for loop and you can use value underscore count for every categorical value so that you will get to know how many times it repeated. See, 1836 in work class particular column, this question mark 1836 times repeated. Similarly, if there is any column, yes, there is one more question mark 1843 times repeated in occupation column. Occupation column also I'm having this now question mark. And if I go ahead and then yes again native country is one more column I have question mark. So that's it. Three different columns are having question mark. Then I'm finding out in particularly work class where exactly question mark is. If my class is equal to work class, my column is equal to work class and value is equal to question mark, these many values are there. 1836. Then I'm treating all of them to null value. Similarly, occupation I identified, so treating them to null value. And native country also I found, so treating them to null value. Okay, got it? After that, now if I see the value underscore counts, these are the things. And then, yeah, after converting them to null value, these are the actual null values. Though these were not identified in the beginning, but we actually modified them to null value because question mark makes no sense. It is representing a null value itself directly. That is why we converted to null value. Now it is time to treat them accordingly. So how do you want to treat them? If you want to remove it, or else if you want to simply drop them, or else you want to replace it with a suitable value, it is up to you. That is depending upon your domain knowledge and what exact value suited to replace it. You have to justify also why you imputed with mean or why you imputed with mode, why you imputed. Okay. So if the data set is huge in size, if it is if it is large in size but the null value count is very small in size, means we can even drop them. In the very beginning of panda session I explained that concept, right? Next, going down we can see data visualization is there. Okay, so how do we know? So use Matplotlib and Seaborn here. Income share and frequency distribution of income. I just plotted here. We can see less than 50K. Okay, people are less than greater than, sorry, less than 50K. People are more than greater than 50K. You can see that means very few people are earning more than 50K according to the data set. All remaining comes under this group. So here you can add one more step if you want to know the count. That is what I just added here. The count by again defined by length of the DF so that we will get the percentage kind of how many out of 75 percentage here we can see less than remaining 24 percentage or 25 nearly going to greater than. Okay, so you can even plot with percentages. Okay, if you are interested you can use this. Okay, anyway it is there. Okay, you can use the same type of visualization for different classes. I mean to say we are also having different classes, right? How many belongs to work class? In work class how much percentage belongs to each class? Means private how many, self employed how many, so that you will get to know where many people belongs to. Here you can see private people are more. Okay, where private classes are more. And then analyze how private employees and then their income, self-employed but not income, then again compare their incomes. So it is not that all private people or private employees will always get more than 50K, right? There are many cases where federal government or self-employment or state government may, those people also may earn 50K and greater than. So that you have to analyze properly which class actually they are gaining more. Then followed by some more visualizations I have just provided. Here you can see how to add this number on top of the bin. This is the program. Okay. Uh, you can get that. Okay. So here palette and percentage annote. This is the function annote, and then center x comma y is defined that x here, y here. So what exact value you wanted to add. Okay. And then followed by uh, one more column where sometimes race is also important. Okay. So just needed to know how exactly they defined according to the income categories. Here you can see largest white is white race. White people are actually gaining less than or greater than both the uh, fields they are there. Followed by marital status, obviously never married people. Here we can see never married people are less here. Income category never married people are more, who are gaining actually less. Here blue means married spouse. That particular category are gaining more salary income. And then some interpretations. Education with respect to education, and here with marital status again count how many are there. We come to know that this is what the field which is gaining more. Then out of all married, how many? The count is here more than 1400 people are. Simple. These are simple. And then numerical columns also. Just if you wanted to know how they are box plots actually outliers with respect to, you can get to know. And then frequency distribution of all the numerical characters. Okay. Then pair plot already I defined. And then these are all the categorical columns in our data set. Okay. You can do one hot encoding or target encoding or label encoding according to your interest. You can just use it and then define them. Then you can, these are the plots, the correlation matrix, then defining the X and Y. Okay, label encoding here, label encoding is what this other is used. You can also use target encoding or one hot encoding according to your preference. But anyway, one class we defined what are these three different things and how to use them effectively. So all, and again, normalization also here using, I also told about normalization and standardization. It is here min max between the minimum and maximum value. All the values will be there arranged. Min max scalar is what we are using here. And this is the final output. Here you can see all the values being converted to numericals. Now this is the data set ready for machine learning. Okay. If you observe our data sets, okay, the output column, if you observe, income 0 is more and income 1 is less. I already told that if your end category column, I mean output column, is not perfectly balanced, it is misbalanced or imbalanced. It is imbalanced data, right? So how do we deal this imbalanced data? Because if we have imbalanced data, there might be a situation where our prediction mostly goes to the zero only because these categories more, correct? So machine has to understand in clear way. So it is imbalanced. Then how do we balance this? There we can use a sampling technique. Okay, here you can see sampling technique. There we can use sampling techniques. More, this is the algorithm. This we can use to define it to balance. Okay, so here you can see now it has been balanced. Then we are going to try and test split here. 80% training, 20% testing, and then goes to the model. And how do we build support vector machine means using the SVC, and then we can use fit to get the score. Here I did not use any hyperparameters like C or gamma or kernel. I did not mention anything. But if you want to really check that using C values from 0.01 to 0.1110, altering different C values and altering different kernels, altering different degrees, and after altering different gammas, you really wanted to know the different accuracies, then you can use this technique. Okay, it will take definitely time. So this was I run before 1 hour. Okay, I mean before you guys joined, I just in the back end I'm just running all these cells. It is still taking me time because these many rows are there, right? It has to go and it has to validate and then it has to come up with the results. So that is why it is still taking time. But anyway, this is the way. If you don't use, if you don't use by default values are there, na? So you can see SVM, sklearn, library documentation. SVC means support vector for classification. Support vector is also used for regression, right? In regression, what is the strategy? Going to find the perfect fit line. Okay. So what are the things it is? See, by default it is one. By default it is one. Kernel by default it is RBF. We also defined, right? What are the three different type of kernels? By default it is RBF. Here you can see RBF. It is effective for nonlinear data. It considers the distance between the data points and as a parameter gamma is there that controls the kernel reach. So gamma is also there. If you don't specify any gamma, by default it is a scale. Okay, degree will be by default 3, coefficient will be 0, shrinking is true, probability is false, tolerance is 0.01, cache size is 200, and max iter is -1, decision free is over. And these all the hyperparameters. Actually there you want, if you want to know every parameter, I already told, please refer this. Here if you type poly, RBF, sigmoid, you can see many kernels are available. By default it is degree 3, considering it is a nonlinear, right? By default it is 3. Gamma means scale, means auto. Scale is nothing but auto, automatically adjusting, that is what. And if you want to specify, you can specify different values. And coefficient value, shrinking, whether to use shrinking heuristic. If you really wanted to know what exactly shrinking, it is provided here. Okay, so regarding the shrinking parameter, if the number of iterations is large, then shrinking can shorten the training time. Okay, and probability, tolerance, cache size, everything you can get to know from this quick information you can get to know. And then you can find the program below. You can even find some more information, notes, fit. Okay, so different ways to use this algorithm. This will really help you if you can understand, sorry, if you can understand these things clearly and implement it in reality. So here, this is one of the ways to use effectively the hyperparameters. Here I'm changing C values from, I already told, right? By default it is 0 0.1, I guess, or 1.0. It is by default 1.0. Okay, it is by default C value is 1.0. Here I am using 0 0.1, 0.01, 0.1, and then 1, 1. It is simply that dividing by 100, then dividing by 10, then 1, then into 10, something like that. Okay, it is a factor of 10. You can see 10 power minus 2 it is. 10 power minus 1. It is 10, 10 by 10. This is what 1. Okay. And then like into 10. Okay. Something like that. The factor is increasing like that. And then kernels also, different kernels I wanted to iterate. One time I wanted to check C value 0.01 and kernel 0 linear and then degree 1 and then gamma value 0. 0.01 gamma. So I wanted to check the combinations of all these four. How do we do? So we can define the grid. There is one algorithm is called grid search CV. There you can pass the algorithm and then the grid values and then CV5 means how many times. Then it will do all the such combinations and all and will do this and then will give you the best parameters. Best parameters for, I mean, for the greater results. Here in our in our thing we got 83 percentage. If there is any best best combination may give 85 percentage. We don't know, right? How do we get to know? If we run this properly, then we will get to know. So Navi base anyway we tried, logistic regression also we tried earlier. So we can see that so logistic is 77 percentage only, and Navi base it is 77 again. But this SVM gave really good results than that. Then out of these three, I can select SVM. Got it? And this is all about SVM. Anyway, I will share it with you this uh, file with data set. Okay, you can run and see how the values be. I mean, how do you get the best results and best parameters